This video is sponsored by Brilliant. Today I want to show you guys how to find the minimum value for this function here. And if this is the first time that you see this kind of question, you might not even know where to start. Because we have 3 square root terms and say, find the minimum. And we have quadratic inside. Maybe we can complete the square to find the vertex of a parabola inside. But X and Y, are you serious? That will tell you though. This right here is just a high school question in Taiwan. It's a typical, it's very classic, and you don't need calculus 3, you don't need multiple variable calculus method for this. So check this out. Firstly, though, notice that we have quadratics inside. And if you complete the square for this one real quick, let me just show you guys real quick. X squared minus 12x, leave a space, well, this is 1 already, so take half of this. Half of 12 is negative 12 is negative 6. Square that, we get 36. So you want to see a 36, and that's 40. So 36 plus 4 will be 40. Factor this, you will get x minus 6 squared, and 4 is the same as 2 squared. Okay, once you complete a square, you get something like this inside of the square root. And you can do the same right here, and let's just focus on this first. Square root of a sum of 2 squares, and we have the x minus 6. What does that remind you of? The answer is the distance formula for 2 points. And let me review that with you guys real quick right here. Suppose we have 2 points. Let's say we have x1, y1, another point here, x2, y2. To find the distance between these 2 points, distance is equal to square root x2 minus x1, and then square that, plus y2 minus y1, and then square that. Have a look. Square root and then sum of 2 squares, just like this right here. So this is the idea behind that. And now you might be wondering, what if that was a cubic? That's another story. I don't know how to do that. But the question is set up very, very nicely. The idea is to recognize that you use the distance formula. Okay. I want to see this is the distance between what and what? X comma something. Well, let's see. I want to force it. So have a look. X is X, minus 6 is minus 6. Okay. But for the 2, maybe we can look at this as 0 and then 2 squared, right? So you can see that we have a point x comma 0, and I will just call that point A, x comma 0. That is a fair thing to do, yeah? Now, maybe we can call another point B, minus 6, so the x coordinate for the point is 6. But now, what's this? It's a 2, but it's a plus 2 or minus 2? And you might be thinking, that should be a plus 2. Yes, it works. If it's a plus 2, that's okay. Let me just put down a plus right here. In that case, what we're looking at is we have a minus 2 for the y coordinate, right? Because you have to look at this as 0 minus negative 2. But if you look at this as a minus 2, that's okay too, because negative 2 squared, you also get the same thing as that, which is 4. If you look at this as a minus 2, then you are looking at this as a positive 2. So it looks like we have 2 choices for the point B. Which one do we pick though? I will tell you it doesn't matter at the moment, because if you look at, let's say, here is x comma 0, and 6 comma 2 is right here. Let's say this is 6. So that represents this distance. But guess what? If you go down to negative 2, the distances are equal. So at the moment, don't worry about this too much. But keep in mind though, keep that in mind, we can have plus or minus 2. Alright, and let's do the same thing right here. I'm going to complete the square right here for you guys. Well, I'll just tell you guys the answer though. You guys do it the same thing, yeah? So you get square root. And for now, it's just y, and then minus 8 is divided by 2, so it's minus 4. So it's minus 4 square, and we need 16, so break down as 16 plus 4. So once again, it's plus 2 square. All right, let's try it. You should get that as well. And put that into the distance formula form. Perhaps I can write this down like this. 2 square, again, that's like a trouble like what we have earlier. And plus y is y, and then minus 4. So I have another point C. Let's say we have 0. So 0 comma y. Good. And then lastly D. And do we have a minus 2 or plus 2, right? So once again, I will just say either plus or minus 2. And then minus 4, so it's 4. Yeah. So we have these 4 points for now. Finally, what's the x squared plus y squared though? In fact, we do not need any other points to consider because we can look at that as the square root. I have x minus 0, so I will just say this is x minus 0 square. And then for the y square, I will purposely write that as 0 minus y squared. Why? Because this way you can see that x comma 0, we have a, and then 0y right here. So these 3 square roots, they represent the distance. The first one is the distance between A to B. The last one represents the distance from C to D. And this one right here represents the distance between A to C. So we have all the points that we need already. Now we just have to look at what the distance that we are talking about. And okay, much better. Now I'm just going to put all the points down and see how they look like. And I'm going to first plot B and D first because we have like actual values for them. So have a look. So we have 6, let's say it's right here. And 2, negative 2. So B can be right here or right here. And then D, negative 2 or 2. And then up 4 right here. So D can be either here or here. Okay, so far so good. Now, remember we're trying to find out the minimum of all these 3 things add up together. So we're trying to find out the minimum distance from A to B, and then from A to C, and then from C to D. So we want to kind of connect it in a nice way, all right? Now, I need to plug A, which is x comma 0. That means the point has to be on the x-axis because the y value is 0. Where do I put it though? Do I put it here? Definitely not. Because if I go from here all the way here, that distance is way too much. Point A should be somewhere in between, right? So that I can just go like this and then go like this or like that. Okay, so it must be somewhere here. I'm just going to put it down right here. And you guys will see why I put it down like there. This is where point A is. X comma 0. And then D is 0 comma y, which is going to be on the y-axis. Similar reason. Do not put it down below, do not put it above, but rather what you want to put is in between of here and here. I'm not going to put it down here either because I don't get a straight line. Remember, if you want to find the minimum distance, it has to be a straight line. So I'm going to do A and this point and then go up like this. This is where the point C will be. Have a look. This is C. In that case, I can connect A and C like this. And then connect A to this right here is B. Of course, if you put B right here, same thing, all right? It's much easier if you look at it like this. So if you connect from here to here, same distance. And finally, this is where I'm going to put down the D like this. Aha, this right here will guaranteed to give you the minimum distance, and that will give you the minimum value for this function here. How do we find out this distance? Well, have a look. I'm going to complete this right triangle. From negative 2 to 4 is 6. And then from negative 2 all the way to 6, this distance is 8. So have a look. This whole distance, which will give you the minimum for that. All I have to do is take the square root of 6 squared plus 8 squared. Just like that. On the inside is 100, square root 100 is 10. So the minimum value for this function is equal to 10. Very cool, isn't it? Hey, thanks for watching the video. Now, as we all know, it's a new year, and if one of your goals is to learn more math and master it in this new year, then I think you'll really like today's sponsor, Brilliant.work. Brilliant is an online learning platform that helps you to get smarter every day with thousands of interactive lessons in math, science, programming, and more. What I love most is how it forces you to think. You are not just passive reading or watching, you are solving real problems step by step, and that's how real learning should be. Personally, I like Brilliant because it reminds me how I learned math growing up, by playing around with ideas and struggling a little until I really got it. It's that kind of hands-on thinking that helped me become a better problem solver, and I see the same effect when I recommend it to my students. And if you're working on algebra or calculus, their courses are especially strong. Everything is built up to help you really understand. Go ahead and visit the link brilliant.work/blackpenredpen or scan the QR code on screen, or you can also click on the link in the description. When you do that, you will get 20% off an annual premium subscription, and now they also offer a free 30-day trial. So go ahead and check them out.